So EMU has had trivia night for a couple years, and I'm pretty impressed when I see the students there. Are EMU student teams better than average groups around the world or whatever of people playing trivia in terms of trivia knowledge? So I tried to test this with a little one sample t-test, and basically the design was there's this site called Sporkle where you can answer trivia questions. And the nice thing about it is you can see the means and standard deviation of results of people who have ever taken it. So all the different trivia teams who have ever played this particular quiz or something. So I did a quiz that in general, the general Sporkle users had scored an average of 9 out of the 15 questions of the quiz. They got on average 9 right. And I was asking this question, are EMU teams better than average trivia teams in terms of the general knowledge? So null hypothesis would be no, they're not better. They're exactly the same. So in that case, if that's true, then the average of EMU teams in general should be 9, because that's what the average is for everyone who's played on this Sporkle site, the teams who have played on this Sporkle site. Now, because I say better than average, that's a directional word. That's one-tailed. I'm not asking if they're worse. I'm only concerned if they're better than. So this is a greater than. The alternative would have a greater than symbol. So the alternative would be the EMU's average is greater than 9 points out of 15 on this particular quiz. So that's a one-tailed test. I need to change that here. This changes um, some of the numbers if you're doing a one-tail versus a two-tail test. So we collected the data. There were 10 teams, gave them the 15 questions. This is amount, the team 1 got 6 right, team 2 got 11 right, and so on. On average, they got 9.4 questions right. Now notice 9.4 is higher than that null hypothesis mean of 9, which was the general Sporkle team that had played. But we can't yet say that EMU teams are better than average, because it could just be that the sample happened to be a random sample with lots of good trivia players in our EMU sample. So could it just be because of randomness alone? Perhaps. That's why we have to conduct this test. So here, if we look down into the p-value, we have a p-value of 0.29. So what does that mean? Remember that our threshold, that limbo bar, is set at 0.05, the alpha level of significance. And the p-value needs to get below that in order to really show that it would be unlikely to get results this far away if the null were true, and then we would reject the null. But in this case, we don't get under that. The p-value is not lower. We don't have that evidence. We failed to reject the null hypothesis. So we would say these results, we did not get statistical significance. If there is a difference, perhaps we didn't pick it up in our sample anyway. So we failed to reject the null hypothesis. And we also can look at practical significance, although if there's not a difference at all, you might argue, well, do we even care how big that difference is? Yes and no. And the reason why is statistical significance is kind of weird in the sense that if you have the higher your sample size, the more likely you are to get statistical significance. And that gets into some weird things. So if you do get a case where your p-value is like 0.06, it's just above that cutoff, well, that's not really much different than a p-value of 0.04. Those, I mean, yes, we call the 0.04 statistically significant and the 0.06 not statistically significant. But in reality, they're almost the same results. So here, if we did look at practical significance, the number of standard deviations that we are above the mean, and we can even see that, right? The E8 minus E2, so this is our sample mean minus the null hypothesis mean, and then we divide that by the standard deviation. That's pretty low. So again, 0.2 is generally a weak effect size, if any. Our confidence interval tells us that we're 95% sure that the average for all EMU teams, now this is tricky, if our sample was representative of all EMU teams, which it probably wasn't, but if it was, then we'd think that the EMU average would be somewhere between 8.11 and 10.69. So notice that the null hypothesis, the general average for this quiz, is in between those two numbers. What we're saying is the EMU average could be a little bit below that 9.0, or it could be above that 9.0. It could go either direction, which is why we ended up not rejecting the null. Now, this doesn't prove that there isn't a difference. When we fail to reject the null, it's not the same as accepting the null. Accepting the null would be, okay, EMU's average is 9.0. That's not what we're doing here. We failed to reject it. We just didn't get enough evidence that a 9.4 would be so far away from 9 that EMU teams must be better. We didn't get that kind of evidence, but it's still possible. We don't really know. So a fail to reject situation is kind of unsettling because you don't really know. You kind of say, all right, well, we're going to go with the null hypothesis for now, but we don't conclude that really is the answer. And one thing you should never do is have things like certainty and prove in your results when you're interpreting the results of an inferential test. There's always this probability, this chance that things could be wrong. It could be that we are better than the average team, and we just didn't pick it up here with our data. So any kind of interpretation of a t-test result that says things like certainly or definitely, don't trust those kind of interpretations. We have evidence. We were not able to get evidence here that the EMU teams are significantly better. Even if we had rejected, even if our p-value had been low, we wouldn't say this proves the EMU teams are better. We would say that we have evidence. The evidence suggests that EMU teams have a higher average, but it still wouldn't be certainly or definitely or anything like that.